Welcome you back for this for the next session on the pneumatic circuits and as well as a pneumatic circuit diagram. See, in the previous case, in the previous module, we had discussed so many different types of valves. See, those different types of valves, what we are using it or what we are discussed that we are using in this sessions. That too, especially while drawing the circuit diagram, or it may be a pneumatic circuit diagram. As a name itself is suggesting that pneumatic circuit diagram, it means that pneumatic control systems, or in a simpler way, where in the control system where air is used as a media to extract the work. Now even here also the systems, what we can say, the circuits, what it has been formed by using a different types of valves. These different types of valves are either it may be a direction control valve, or it may be a flow control valve, or it may be a pressure regulating valve, or it may be a shuttle valve, or so many types. These valves are used for the designing of the circuit, and also in the circuit to get the exact output. Now here the main function of the what we can say the pneumatic circuits are, the first one is nothing but the controlling or the how the flow is from the entrance to the exit is taking place, that it is representing in the case of the pneumatic circuit diagram. The second one is and another thing is how the control is taking place by means of another valve. See, here in this case, either it may be in the case of the pneumatic control valve, or it may be a hydraulic control valve. We are not using only one control valves. There are n number of control valves we are using it. Okay, depending upon the type of the application, what control valve is mechanism is implemented and how it is controlling the another valve, that we are discussing in this. That is another main function with respect to the pneumatic circuit diagram. The third function is nothing but the actuator and also other pneumatic devices which are working it, how it is working it, and what are all the different methods, and also what are all the different types of valves it has been used to control the circuit that we are discussing in details. Especially in the pneumatic circuit diagram, it consists of the what we can say the three major thing: the entry and exit, and also the different types of valves, and also the actuators. See, these are the three basic elements, but how it is controlling it and what action it is performing it, that is also a most important. For that reason only, before implementation the pneumatic circuit diagrams, or it may be pneumatic circuit is drawn, and then afterwards it is tested for the functionality, and then it is implemented. This is a small introduction with respect to the pneumatic circuits and also pneumatic circuit diagram. The next part, the direct control of a single acting cylinder. See, as you know that the single acting cylinder, it consists of the only one thing. The input it will be there. The output or it may be in the forward motion. The control mechanism, it should be through the valve, and the reverse motion, or it may be the retraction, it can be done by using the spring force. That is a simple explanation with respect to the what we can say the direct control of the single acting cylinder. In the case of the pneumatic cylinders, can be controlled by the actuation of the DCV valve. Now in this circuit, it consists of the single cylinder, and also the one is a DCV valve. Even this DCV valve is also operated by means of what we can say a push button. See, when the push button is switched on automatically, the compressed air is made to flow. That is a small triangle, it is which is represented by means of 1 is nothing but a compressed air. The compressed air is made to flow through the wall and then to the actuator, where the piston is moving from the what we can say to the left to the right, where the extension or the expansion stroke is taking place. Then the same if it is pushed off, if the same button is pushed off, then what will happen? The exhaust port, the air what it has been accumulated there, through that it is moving out. That is nothing but 2 to 3, from 1 to 2, that is the extension stroke is taking place. In the next sketch where the flow is in the reverse one, that is nothing but 2 to 3, where the expelling of the air from the actuator cylinder is taking place. And even the retraction of the cylinder, or it may be the piston, is done because of the what we can say the spring force which is acting on the cylinder. See, that is a very simple explanation with respect to the direct control single acting cylinder. See, as you know that the direct control, it means that the another control will also be there, which is nothing but a indirect control. The next topic what we are discussing is with respect to the indirect control of the single acting cylinder. In this type of cylinder, a suitable a single acting cylinder will be there, which is operating at high speed. Now here in this case, especially in the case of the single acting cylinder, what we are using is nothing but a 3x2 valve, a 3x2 push button, or it may be a push button operated valve. Now the final control of the valve is handling with a high quality or a huge quantity of the air. When the push button is pressed, 3x2 valve normally which generates a pilot signal which is 1 2, which controls the final valve, thereby connecting the working medium to the piston side and the cylinder so as to advance the cylinder. Now in the schematic diagram, where you can see once if the push button or the switch is pressed, automatically the compressed air is passed through the what we can say 3x2 DCV valve. Once if it starts passing it from the 1 2, again it is moving inside to the cylinder, where the extension of the piston or the movement of the piston from the left to right is taking place. The same way, if the push button is released automatically the what we can say the reverse action, or it may be a retraction is also taking place through the what we can say the DCV valve, 3x2 DCV valve only. See, this is a small explanation with respect to what we can say the indirect control the single acting cylinder. Now the single pilot valve is rarely used in application where the piston has to retract immediately on taking out the what we can say the set of the pilot signal. See, in the case of the retraction force, automatically the flow it should be a continuous one, but in the case of the expansion or extension stroke, it is not a continuous one, where that depends upon the what we can say the load. It is the extension is taking place in a sequential way, but in the case of the retraction, a sudden release it is taking place and it is moving back. See, the next part what we are discussing is with respect to the flow control valves. See, the flow control valves we have discussed. As a name suggests, that it controls the flow rate of the fluid through the hydraulic circuits. That is a simple explanation with respect to what we can say the flow control valve. See, the flow control valve accurately limits the volume at which it has to be flown in the circuit. The function is to provide the velocity control, or it may be the linear actuator, or it may be speed control of the rotary actuator. Now here in this case, by using typically a flow control valve, it is very difficult to control the action, or it may be the control the unit quantity of the flow of the air into the cylinder. See, that is very difficult. See, typically what will happen, a fixed displacement pump or a size to a supplied maximum system volume flow rate depends. Now in an industrial application, the feeding the two or more branch circuits from a one pressurized manifold source or a oversupply of the fluid in any circuit operated by itself is virtually assured. The mobile applications to the supply of the branch circuits and as well as the power steering and as well as the front end loader from the pump posed to a similar situation. Now here in this case, if the unrestricted branch circuit receives us a oversupply of the fluid, would operates at the greater, or it may be a specified velocity, which may leads to a what we can say a increase, or it may be a damaging of the work, or it may be a circuit failure, and all those things it is taking place. For that reason only, here in this case, what we are using, especially in the case of the flow control valve, even the check valve also comes under the category of the flow control valve. The throttle valve is also comes under the category of the throttle valve. Sorry, the throttle valve is also comes under the category of the flow control valve. Now, once if we start clubbing in a line which is forming a one-way flow control valve, then what we can say, the entire circuit it will be in a safer condition. For that reason only, in most of the applications, the one-way flow controlled valves are used. The next part is nothing but the speed control of the cylinder by using the FCV. See, FCV is nothing but it's not the flow control valve, by using the one-way flow control valve. Okay, now here, as we know that the supply of the air that depends upon the what we can say the speed. Even here also, if you start using only either it may be a check valve or it may be a throttle valve, it is very, very difficult to control the speed. For that reason, if you start using a one-way flow control valve in the circuit, the speed it can be controlled very easily. The speed control is possible either by regulating the air at the inlet port while actuating, or at the outlet port. Now, as the name itself is suggesting it, the control it can be done either at the inlet port or at the exhaust port. See, depending upon the type of the application, the throttling where it has been done, either the supply air throttling or the supply exhaust throttling. These three are discussed in detail in the further slides. If you start comparing with respect to these two, it is based on the concept either it may be a meter in or it may be a meter out. The next part what we are discussing is with respect to the supply air throttling and exhaust air throttling. Now, it is always necessary to reduce the speed of the cylinder from a maximum speed to the selected speed, or it may be operated speed. Okay, the final control valve to the normal speed depending upon the type of the application. The speed control of the pneumatic cylinder can be conveniently achieved by regulating the flow of the either it may be the air at the inlet or at the exhaust. The volume flow rate of the air can be controlled by using a one-way flow control valve, which can be either the two-way flow control valve or it may be a one-way flow control valve. See, these are there are two types of what we can say the throttling mechanism. It can be done in the case of the double acting cylinder, that is not either it may be at the supply air throttling or it may be at the exhaust air throttling. Now what we are discussing is with respect to the supply air throttling. As the name itself is suggested, the supply air throttling, it means that in a simpler way, it is also called as a meter in circuit, where the supply air at the inlet is controlled. A one-way flow control valve is installed so that the air entering into the cylinder is controlled, or it may be a throttled, by which the operating of the cylinder, or it may be the movement of the piston inside the cylinder can be controlled. The exhaust air can escape freely through the check valve of the throttle valve on the outlet side of the cylinder. Now, the schematic diagram shows the supply air throttling. See here, it consists of the DCV valve. This DCV valve automatically it is in turn connected to a one-way flow control valve. Even in this one-way flow control valve also, it consists of the throttling valve and also the check valve. Now here put together is nothing but a one-way flow control valve. That one-way flow control valve is placed at the inlet circuit. Once if it is placed at the inlet circuit, automatically the controlling it can be done very easily. That's why it is called as the supply air throttling.